Hello everybody and welcome back. We're going to do 4.2 again, and it's all going to be about the unit circle, which is exciting. Whoop, 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 whoop. So we are going to really dig deep into the unit circle today and start figuring out not only the points on the unit circle like we did in 4.1, but actually like the coordinates of those points. So either the degrees or radians, things like that. So we have 4 objectives today. The first objective is to identify a unit circle and describe its relationship to real numbers. Then we're going to evaluate trigonometric, spelling is hard today. I was ahead of myself. So we're going to evaluate the trig functions using the unit circle. So using that unit circle as a tool, we can figure out the values of different trig functions. Then we're going to use the domain and period to evaluate sine and cosine. So we're going to look just at sine and cosine functions today. And then we're going to use a calculator to evaluate, zoned out. Use a calculator to evaluate trig functions. So how can we enter those into our calculator? So the first thing that we're going to talk about the unit circle just a little bit more. Okay, so the unit circle specifically is a circle with radius of 1. Okay, so here's my terribly drawn circle. It's actually not so bad. And the radius here is 1. Okay, the equation of this circle is x squared plus y squared equals 1. Remember that the x squared not having a number there and the y squared not having a number there tells me that the center of this circle is at the origin, is at 0, 0, right? And then the 1, if I take the square root of 1, I get 1, and that's my radius. So my radius is 1. So that's just how we have the equation. And then again here, because here's my equation to find the arc length. Because my radius is 1, in the unit circle, that r just goes away because it's just 1, and I just get that the arc length is equal to the angle. Okay, whether that angle is in degrees or radians, but remember that in that equation specifically, we're looking at radians. Okay, so what we're going to look at today is using the unit circle to define trig functions. So remember we talked about, I want to say it was in 4.1, about how this whole unit is kind of going to be looking at, not the whole unit, but a lot of this unit is going to be looking at triangles, whether or not those triangles are drawn, right? So here's an example. Here's an angle. The angle's T, right? We don't know what it is, but it's T. And then drew the unit circle, and then we have a ray that intersects the unit circle at point P. So what that has actually created is a triangle. So even though we don't usually draw the triangle, there it is. And this angle right here is angle T, which it's already labeled. Okay. What we do, I already know that from the origin to point P is 1, because the radius of this circle is 1. And then what we say is the distance here along the x-axis, or the horizontal distance, we can just call it x. And then the vertical distance is y. So point P is at the point x, comma, y. So that's this coordinate. And then we're just using SOHCAHTOA. So hopefully we remember SOHCAHTOA. Right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So T is a real number, right? It's an angle. The point is at x, comma, y. So that tells me that sine of T is opposite over hypotenuse, right? So I'm going to write this off to the side. Sine of T is equal to opposite, which is y, over hypotenuse, which is 1. Well, y over 1 is just y, so that's how we get this. Sine of t equals y. I'm going to go ahead and erase this, okay? Because it's just y over 1. Same thing here, cosine of t. Well, cosine is adjacent over hypotenuse. So here's t, right? My adjacent side is x. My hypotenuse is 1. So I get x over 1. Well, x over 1 is just x. So that's how we get cosine of t is x. Tangent is opposite over adjacent. So right here, tangent of t is opposite, which is y, over adjacent, which is x. The only thing is x cannot be 0, right? Because I can never have 0 on the bottom of a fraction. So that hopefully is not something new. We did that in geometry and probably a little bit in algebra 2 as well. These three down here maybe are new. These are the inverses, or sorry, the reciprocals, not the inverse, the reciprocals of sine, cosine, and tangent. So this one right here is called cosecant. So I'm going to write it out so you can see what the word is, right? Cosecant. And it's just the reciprocal of sine. So if sine of t, I guess I shouldn't have erased it, is y over 1, then the reciprocal of that, the cosecant of t, is 1 over y. I've just flipped the fraction. So this is 1 over sine. Okay. The next one is secant. Secant. This is going to be 1 over cosine. It's the reciprocal of cosine. So if cosine of t is x over 1, then secant of t, right, the reciprocal is 1 over x. And then the last one is cotangent, which is the reciprocal of tangent. So if tangent is y over x, then cotangent is x over y. And so that is just the reciprocal of tangent. So those three are new, but they're just the reciprocals. So hopefully nothing too crazy going on here. Okay. If you have questions on this, just make sure that you reach out and let me know. All right, let's look at finding the values of these trig functions at certain points. So it says find approximations for the coordinates of the points on the circle at 0 degrees, 30 degrees, 45, 60, and 90. So at 0 degrees, it's right here, right? And that coordinate point should be very easy. It's 1, 0. I know it's 1 because the unit circle has a radius of 1, right? And that's just pretty straightforward. I know what that point is. Same thing at 90. 90 is right here. So this is the point 0, 1. I'm just crossing them off as I do them. So that should be, those two should be pretty straightforward and easy. Again, the radius is 1. Now let's do some other ones. Let's do this guy right here at 30 degrees. Okay, so this is kind of like, you know, doing something like this. It's really hard for me to tell what that is. But as I go across here, I can see that the y coordinate is 0.5. So my x coordinate here, I'm just going to tell you, is 0.87. And then my y coordinate is 0.5. Okay, I don't really like the idea of 0.87. So we're going to find out what that exact value is. I know that the exact value of 0.5 is 1/2, so that's easy. But I want to find out what that is. The easiest way to do that is to draw a right triangle. Right? Here's my right triangle drawn. Right there. Oh gosh. Right? Where this is 30 degrees. I know that the radius of the triangle, or of the circle, is 1. So that's 1. And I know that this value right here is 1/2. So there's lots of options here. I can use SOHCAHTOA. I can use my information from right triangles, which we looked at in 4.3. There's a lot of different ways I can figure out what this value is. But basically, the other thing is I can use what I know about 30, 60, 90 triangles, right? Which tells me that whatever this value is times 2 gives me this value, right? And then whatever this value is times square root of 3 gets me the side along the 30. So 1/2 times square root of 3 is square root of 3 over 2. So that would be the exact value there. So that's cool. That kind of leads me up to a 60. Let's do this one. 60, so I did 30, right? Because this is 60 right here. So 60, I see if I go down, I'm at my x coordinate is, let's do it in decimal first. My x coordinate is 0.5, and now my y coordinate is 0.87. So 60 to 30, those coordinate points have just switched. So it's 1/2 now, and then the y coordinate is square root of 3 over 2. So 30 and 60 are just switched, the x and y. And then the last one they want us to do is 45, which is right here. Which again is really hard to tell, right? If I like go down, it's not quite at 0.7. This is actually 0.71. And then if I go across, it's actually at 0.71 again. And again, I don't like those decimals, so we can figure this out by drawing the triangle where this is 1. I know that because the radius of the circle is 1. This is 45 degrees because that's what I'm finding, which makes this also 45 degrees. And I can use what I know about 45, 45, 90 triangles. That tells me whatever, so this side, and this side are the same length. They have to be the same length. Okay, so I can use Pythagorean's theorem, or I can use, again, our rules about 45, 45, 90 triangles. There's lots of stuff that we can do. But we find that this is the square root of 2, and if that's the square root of 2, this one also has to be the square root of 2. Sorry, over 2. Lots of 2's. So I get the square root of 2 over 2, comma, square root of 2 over 2. So this is this is just quadrant 1, right, of our unit circle. This is kind of like the quadrant. If you don't know the entire unit circle, you at least need to know quadrant 1. And when we are in class, we will go over the little hand trick. There's a trick on how to help you memorize or understand what these coordinates are. Okay, but these are just the coordinates of the unit circle for the first quadrant. So what we're going to do is you have a blank unit circle on the next page. I want you to go ahead and hit pause on the video, but I want you to fill in the degrees of the unit circle, fill in the radians of the unit circle, and then fill in at least quadrant 1 of these coordinates. However, I think that you'll see that they're just the same in the other quadrants, just maybe positive or negative, depending on what quadrant you're in. So I want you to do your best to fill out the unit circle on the next page. Before I let you go and just do it for a little bit, oh, never mind. There was an extra line drawn on my unit circle that's not on here. So never mind. So I know it's a little blurry on here, but I want you to go ahead, pause the video, and fill in as much of this unit circle as you can. Notice the degrees are here. This would be the radian, and then this would be the coordinate. When you are ready to check your work, you can go ahead and hit play and we'll check our work. Okay, so here is quadrants 1 and 2. Obviously, I can't fit the entire unit circle in. But for quadrants 1 and 2, hopefully you notice that the x and y coordinates for our main angles, I guess, on the unit circle stay the same. It just depends on whether they're positive or negative depending on the quadrant. So in quadrant 1, both your x coordinate and your y coordinate are going to be positive because of where they are, right? So your x coordinate, these are positive x values, and then when you go up, those are positive y values. For quadrant 2, because you're going to the left, your x coordinates are going to be negative. Notice it's negative 1/2, negative root 2 over 2, negative root 3 over 2. And then your your y coordinates are going to be positive because you're going up. So pi over 3 and 2 pi over 3 have the same coordinates. The only difference is that the 1/2 is negative at 2 pi over 3. If you haven't done so, you can go ahead and do quadrants 3 and 4 and then check your work, and I'll go ahead and fill that out now. All right, so here's quadrants 3 and 4. Again, if you notice, the coordinates are still the same. They're just changing their signs, either negative or positive, depending on the quadrant. So over here in quadrant 3, I have negative x and negative y, right? Because I'm going to the left and down. And then in quadrant 4, my x is positive, but my y is negative because I'm going to the right and down. But again, so that's really why I was saying as long as you know the first quadrant, you have those coordinates. Then they're just changing depending on what quadrant they're in. What we're going to do now is we're going to look at evaluating these trig functions. And I want to say that we're mainly going to look in quadrant 1, but that's actually not true, so never mind. But keep this, what am I trying to say? Wow. Keep this unit circle handy for the next thing that we're going to do. Okay, so here we have this grid, and we're going to evaluate all 6 of those trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, at each of these real numbers, at each of these radian values. So if you have that unit circle handy, that's awesome. If not, that's okay. But remember that the sine of t is just y, right? That is what we filled out on the very first page of this unit, or of this lesson, excuse me. So it's just the y value. So if I go to pi over 6, okay, so if I go to pi over 6 right here, I want the y value. Well, the y value of that is 1/2, right? The y value of that coordinate is 1/2. So sine of pi over 6 is just 1/2. Then, excuse me, knowing that sine and cosecant are reciprocals of each other, right? This is 1 over y. It's the reciprocal. So that tells me it's the reciprocal of 1/2, which is 2 over 1, which is just 2. So the sine of pi over 6 is 1/2, and the cosecant of pi over 6 is 2. Now let's look at cosine. So again, if I go to pi over 6, cosine is the x value, which is root 3 over 2. Right? So remember, this is the x value, which is root 3 over 2. Now cosine and secant are reciprocals of each other. So I can easily find the secant of pi over 6 as well by taking the reciprocal. So I get 2 over root 3. Now something special happens here. I'm not allowed to have root 3 on the bottom. Can't have a square root on the bottom. So I have to do what we call rationalize the denominator, where I'm going to multiply both the top and the bottom by root 3. Root 3 over root 3 is 1, so I'm just multiplying this by 1. So it's not necessarily changing the answer. I'll probably never find that same blue color again, so that's okay. So this gets me 2 times root 3 over, and then root 3 times root 3 is just 3, right? That square root cancels. So the secant of pi over 6 is 2 root 3 over 3. And then the last one is tangent. Remember that tangent is y over x, right? So it is, and I'm not going to have a whole lot of room here, so write small, okay? Y, which is 1/2, over, oh gosh, let me write smaller even. So 1/2 over root 3 over 2. So how I really write that is 1/2. I'm just going to go over in these boxes so that you can see. Okay, so 1/2 divided by root 3 over 2. Well, how do I divide fractions? Copy dot flip, right? So copy dot, and then I'm going to flip. So I keep going. 1 times 2 is 2, and then I have 2 root 3. Can't have that square root of 3 on the bottom, so I have to multiply by root 3 over root 3. I get 2 root 3 over 2 times 3. The 2's cancel, and I just get root 3 over 3. Whew, that's a lot of work, right? So the tangent of pi over 6 is root 3 over 3. That is something that is worth writing here. So notice right here, I wrote that the tangent is root 3 over 3. So then therefore, I should be able to find the cotangent, right? It's just the reciprocal. So instead of root 3 over 3, it's 3 over root 3. Again, I can't have the root 3 on the bottom, so I multiply by root 3 over root 3. And I get 3 root 3 over 3. Well, the 3's cancel, and I just get root 3. So the cotangent of pi over 6 is just root 3. So I'm going to kind of clean this up a little bit, and then we'll look at 5 over 4 as well. Okay, so now we're going to do the same thing with 5 pi over 4. 5 pi over 4 is located down here in quadrant 3, right? There it is right there. And so we're going to go through and we're going to fill out all 6 of my trig functions. Okay, so the sign is the y value. So the y value at 5 pi over 4 is negative root 2 over 2. Okay. Then down here, I can take the reciprocal of that. So negative 2 over root 2. Can't have the root 2 on the bottom. So I'm going to multiply by root 2 over 2. And I get negative 2 root 2 over 2. These cancel, and I just get negative root 2. So the cosecant of 5 pi over 4 is negative root 2. Now the cosine is the x value of that, which is also negative root 2 over 2. So lucky for us, for the secant, I can automatically say that the reciprocal is just going to be negative root 2. Okay, now the tangent is a y over x. So I have negative root 2 over 2 over negative root 2 over 2. Well, anything over itself is just 1. And then because they're both negative, I'm going to get a positive 1. And then for cotangent, the reciprocal of positive 1 is just positive 1. So there I was able to figure out the rest. So what I want you guys to do is I want you to try C, D, E, and F using your unit circle. I want you to go through, find the sine, cosine, tangent, and then also the reciprocals, the cosecant, secant, and cotangent. And then when you are done, you can go ahead and hit play on the video and we can check our work. All right, so this is what we're looking at for C, D, E, and F. For C, we're looking at 0 radians, right? So that's right here. Oh boy, sorry, 0 radians. So my sine value, my y value is 0. My x value is 1. 0 over 1 is 0, right? Now here for cosecant, if I take the reciprocal, so 0 is like 0 over any number, let's just do 4 or whatever, right? If I take the reciprocal of that, I get 4 over 0. Well, I can never have 0 on the bottom of a fraction. So that's why for my cosecant, I get 0. Okay, I can never have 0 on the bottom of a fraction. So that's what's going on there. The reciprocal of 1 is 1, so my secant is still 1. And then again for my cotangent, my tangent is 0 over 1. So if I take the reciprocal of that, I get 1 over 0. And again, I can't have 0 on the bottom of a fraction, so my cotangent is undefined. And that's why it's undefined here at pi as well. I can't have 0 over negative 1 I can't have negative 1 over 0, so it's undefined. Then for negative pi over 3, just make sure that for that one, you guys, that I'm starting here at 0 and I'm going negative pi over, oh gosh, it's really hard to follow this. Negative pi over 3. So we're actually looking here at, what is that, 5 pi over 3. Okay, so that's where we're getting all of those coordinates from, is 5 pi over 3, because it's negative. So negative. And then same thing here for negative pi over 2. So negative pi over 2 is going to be down here, right here, because you're going in the clockwise direction if it's negative. If you have any questions on those, just make sure you reach out. We can go over any of these. This was just kind of examples. You know, obviously there's plenty of other radians on the unit circle that I could ask you to find the trig functions for. These were just some examples. The next thing that we're going to look at is sine and cosine specifically, and we're going to talk about the domain and range and how do we use information about sine and cosine to help us solve problems. Okay, so first let's talk about the domain and range of sine and cosine. I know that when we think of domain and range, we think of the vertical line test. But you can't use the vertical line test on the unit circle, which is very confusing because you're like, oh, it's a circle, you should be able to use it, right? Or not the vertical line test, sorry, but just being able to look at the unit circle and say domain and range. For the domain of sine or cosine or tangent is any angle that you can plug in. So the domain is the set of all real numbers, right? Because I can find, I'm going to switch to degrees just because it's easier for right now. So I can find the sine of 150 degrees, or I can find the sine of negative 3,234 degrees, or I can find the sine of positive 15,783 degrees, or whatever, right? So I can find the sine or cosine of any degree. So just keeping in mind that the domain, and if you need to make a note of that in your notes, please do so. But the domain, what we're talking about is what angle values can I plug in, okay? Then the range is your actual, what can I get out for sine and cosine? So when I look at sine, it's my x value or my y values, right? So the lowest y value I have right here is negative 1. And then the highest y value I have is positive 1. So I'm not going to get a sine, an output of, 6 or whatever. So my range is anything between negative 1 and 1 because the radius of the unit circle is 1. And that is the same for cosine as well, right? So cosine is your x values. So here I have my smallest value is negative 1, and here my biggest value is 1. So I can't have anything outside of negative 1 to 1. So, oops, my bad, the wrong thing. Okay. So we're going to use the period and even odd information to evaluate trig functions. So we're going to learn how do we evaluate these trig functions, specifically with sine and cosine. So I want you guys to think of science, when we talk about like waves or, if something swings back and forth, things like that. In science, we talk about it having a specific period. And so the period is just basically how long does it take to go from one starting point back to the same starting point. So, if I start here, right, and then I do this and I end up back here, I'm at the same starting point as I was. These 2 points are in line with each other. So how long was that distance, for example? So when we're talking about sine and cosine, so right here, when we're talking about sine and cosine, the period is 2 pi, meaning it takes 2 pi radians to go to the same point. So let's look at a unit circle. Oh gosh, that was bad. But if I start here, how long does it take to go all the way back around here? And it's 2 pi, right? So if this has the sine value of, let's just do this as 1/2 and then root 3 over 2. Let's do it as pi over 3, right? How long will it take for me to get back to the sine value of root 3 over 2? And it's 2 pi. Same thing with cosine, right? How long will it take me to get back to 1/2? And it's 2 pi. When I'm talking about tangents, it's a little different, and tangents have a period of pi. For example, on a unit circle, this right here has a tangent of 1. Oops, not. Apparently my writing skills today are subpar, you guys, so sorry. So this has a tangent of 1, but then this point also here has a tangent of 1. So it only takes a pi rotation halfway around the circle for it to get back to itself. So that's why the period is pi. Well, when we talk about an actual graph, though, when we're going to be graphing sine and cosine, if this is my starting point, a graph will do this. So this is the graph of sine, and then it gets back here. Notice that this is the same point as this, right? They're both at 0. It's the equilibrium. So that this distance right here is 1 period. And because this is sine, the period is 2 pi. So the distance from this point to this point is 2 pi. So if this is 0, this is 2 pi. And that period can change as the equations change, but we're just going to focus on the parent graph, I guess, more or less. So let's look at the next part, which is even and odd. Okay, so cosine and secant, the reciprocals of each other, are the only graphs that are even. All the other graphs, sine, cosecant, tangent, cotangent, are all odd. Okay, so basically what that means is, again, is even and odd last time. If I plug in a negative number, if I get out the same equation but it's negative, it's odd. But if I plug in a negative number and I get out the same equation as the original, it's even. So I wouldn't focus too much on that. We'll talk about it a little bit, but this is really what we're going to be focusing on right here is example 3. So example 3 just wants us to find the following. Okay, so here, find the following. I notice, and again, we have to be good with fractions, 12 pi over 6 is equal to 2 pi, right? That is all the way around. That is one full rotation. So 13 pi over 6 is 2 pi, right? 12 pi over 6, plus one more pi over 6. So if I were to graph it, it's all the way around, great, and then 1 more pi over 6, which is right here. The coordinate of that is square root of 3 over 2, comma 1 half. So the coordinate of that angle is root 3 over 2, comma 1 half. So we have to remember which one is sine and which one is cosine, right? The x-coordinate is always cosine, and the y-coordinate is always sine. So if I want sine of this angle, it's just 1 half. And that's it. Same thing here. Okay, I'm talking about negative 7 pi over 2. If it helps you to draw a visual, you can. First of all, we're going negative, so I have to go clockwise. So here's 1 pi over 2, 3 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So this is the angle I'm interested in. The coordinate of that angle is 0, 1. And really, I don't need this graph or the drawing. Sometimes it just helps visually, but if you can do it in your head, then go for it, okay? So my coordinate here is 0, 1. And I want the cosine. Remember that the x-coordinate is the cosine and the y-coordinate is the sine. So if I want the cosine of this, it's 0. Okay. Okay, the next one says if sine of some angle, we don't know what the angle is, but if sine of some angle is 4 over 5, find sine of negative that angle. So I'm going to draw a visual because that's what I do. I don't know what the angle is, right? This is t. I have no idea what this angle is. But I know that sine, which is the y-coordinate, know that sine of this right here, I don't know what x is, but I know that the y-coordinate is 4/5. That's a really ugly 5. It's hard to write that small. Okay, so I know it's 4/5. Now, if I were to take that same angle and go negative, be down here, right? This is negative t, right there. I still don't know what the x is, but now I'm going down, right? I'm going down. Instead of up 4/5, I'm going down 4/5. So the sine now is negative 4/5. So sine of negative t is now going to be negative 4/5. Because of how that worked. Okay, so we have 6 here for you to try. Give it a shot. If you get it wrong or whatever, that's fine. We can fix it. Okay, but trying it is going to be very, very helpful for you. So I want you to go ahead and try D through I, and then we'll go over them. Okay, so let's quickly go through these. If you drew it and that was helpful to you, awesome, right? So here, 3 pi, here's 1 pi, here's 2 pi, here's 3 pi. So this is the angle I'm looking at. The coordinate of that angle is negative 1, 0. And so I want the cosine of that, which is my first term, my x-coordinate. So my answer here should just be negative 1. For E, I'm going negative 11 pi over 2. Okay, so I know that 4 pi over 2, negative 4 pi over 2 is 2 pi. And then another 4 pi over 2 is, so far that's 8 pi over 2, right? So that's around twice. That's around once, that's around twice. And then I have another 3 pi over 2. So then another 3 pi over 2 is here. So however you got to that point is swell. That coordinate point is 0, 1. I want the sine value of that. So that is the y coordinate. So in this case, my answer is 1. For f, I have tangent is 2 over 3. Now keep in mind, tangent of t, so let's just call this t, right, is 2 over 3. If I go that negative t, here, tangent is y over x. So my y is positive and my x is positive. So it makes sense that this is positive 2 over positive 3. Here, my y is positive, right? Or sorry, my x is positive, but my y is negative. So my y is negative, but my x is still positive there. So tangent of negative t now is negative 2 over 3 because of what quadrant it's in. It's moved quadrants. Same thing here, 9 over 2. 9 pi over 2 is what I'm looking at. So I know that 4 pi over 2 is a 2 pi. Another 4 pi over 2 is 8. And then there's a 1 pi over 2. And that gets me to 9. So this is 2 pi plus 2 pi plus pi over 2. Well, 2 pi, and that just goes all the way around. So I can kind of ignore that and just kind of look at this. And that tells me that pi over 2 is right here. So the coordinate for that is 0, 1. Now that I know the coordinate, I can find tangent. Well, remember, tangent is y over x. So in this case, my y is 1. My x is 0. I can never divide by 0. So my answer here is undefined. So tangent of 9 pi over 2 is undefined. For h, I have cosecant of negative 8 pi over 3. So again, I know that negative 6 pi over 3, right, is 2 pi. So that's all the way around. And then I have another 2 pi over 3. So again, this is all the way around. I don't really care about that. So negative 2 pi over 3, there's 1 pi over 3 and 2 pi over 3. It's somewhere here. So using the unit circle, right, I know that this is the x coordinate is negative 1/2 and the y coordinate is negative root 3 over 2. So once I have those coordinates, that'll help me find whatever it is I'm trying to find, which in this case is cosecant. Remember that cosecant is 1 over y. 1 over y. So I'm going to take the reciprocal of y. So I'm going to keep the negative up top. Negative 2 over root 3. So I'm taking the reciprocal of my y coordinate. I can't have root 3 on the bottom, so I'm going to multiply by root 3. And I get negative 2 root 3 over 3. And that is my cosecant. And then the last one, if secant of t is 7 over 4. So again, here's t. Right? Secant is the reciprocal of cosine. So just keep that in mind. So that tells me that the cosine of t is equal to 4 over 7. That tells me that the hypotenuse is 7. So this is clearly not on the unit circle. The hypotenuse is 7, and my cosine, which is adjacent, is 4. Okay? So then it wants to know negative t. So here. negative t. Okay. Well, my hypotenuse is still 7. That hasn't changed. That's not negative, right? So the sine value is negative. And then my x value, my cosine, is still 4. So the secant of negative t actually here stays the same. It's 7/4. And you can use that even and odd feature as well. It's just sometimes hard to remember which ones are even and which ones are odd. So because the 7 is still positive and the 4 is still positive, this stays the same. The last thing that we're going to do in this lesson is learn how to use our graphing calculators to find these trig functions. And so the first thing that you're going to need, one, is your calculator. But the biggest thing is learning how to change between the modes. Learning when to use degrees, when to use radians, okay? So the first thing you need to do is you click on mode on your calculator. It's right under alpha. Let me get my calculator. Oh, sorry, it's right next to the second, right there, mode. Okay, and then you need to scroll down and make sure that your calculator is on radians. Okay, it's about the fourth one down. Okay, so make sure it's on radians. If I ask you to enter the cotangent of 47 degrees, you need to make sure your calculator is in degrees. If it's like these, where it's not in degrees, then you need to make sure your calculator is on radians. The biggest, the most common mistake on any of these is you're doing a question with degrees, and then the next problem has radians, and you don't switch it over. Okay, so you need to make sure that if the problem is giving you angle measures in degrees, that you are in degree mode. If the problem is giving you angle measures in radians, you have to be in radian mode. But after that, it's really just entering these into your calculator, right? So sine, you hit sine of 2, and I always use the pi button. Ooh, always use the pi button, okay? Don't ever just do 2 times 3.14, okay? And so this is what it should look like when you're entering it. Sine of 2 pi over 3. Hit enter, and there is my answer. And again, I'm in radian mode. It also tells you right here on the main screen what mode you're in, so that's kind of helpful. So I'm in radian mode because this problem gave me the angle measure in radians. So this is approximately 0.866. Go ahead and try the other 3, and then when you're ready to check your work, you can go ahead and hit play on the video. Okay, so here are the 4, or the other 3 answers. For both B and D, make sure that you are using the rule about the reciprocals, okay? So cotangent is the reciprocal of tangent, not the tangent inverse. So see where it says here the tangent inverse? That is not what you are using, okay? You are not using the tangent inverse. It's the reciprocal. So I would do 1 divided by tangent of 1.5. So this is what it ends up looking like in my calculator. Okay, 1 divided by tangent of 1.5. And that will get me the correct answer. So you want to just make sure that you're being really careful. Same thing with D. I would do 1 divided by sine of pi divided by 18, like so. And that's how I got that answer. So just make sure that you're not using the inverse trig functions, you're using the reciprocal of those trig functions. We are not going to do the application problem on the next page. So that is it for lesson 4.2. No, it was a long one. Thanks for sticking by. If you need help on any of this, this is all foundational stuff, guys, on the unit circle. It's hard. This is the time to be asking for help, not 2 units from now when we're using all of this information to do things. So make sure that you're reaching out for help if you need it, that you are going through Zooming with me, coming to class, whatever it is that you need to do to make sure that you're getting a good understanding of what's going on in the unit circle. Okay, I will see you guys later. Have a wonderful day.